Fire alarm addressable systems. In this presentation, we're going to be looking at addressable fire alarm system overview and system designs, notifying device loops, DCLC addressable fire alarm systems, and finally, dual stage addressable fire alarm systems. Addressable fire alarm systems are known as data communication link systems. These require smart field devices or modules and a smart fire alarm panel. The fire alarm panel can then pinpoint the location of a signaling, smoke alarm, or pull station, not just the zone. Most systems provide communication and power to devices over the same two conductors. The system labor, splicing, and design complexity is actually a little bit reduced when compared to a conventional system. And if we were to look at both of them side by side, on the left, a conventional system, each zone required its own separate wiring. On an addressable fire alarm system, each zone does not require its own separate wiring. And so we'll see why that is as we go through the presentation. This is an example of an addressable fire alarm panel, and you'll notice it has all of the same requirements as what we saw in a conventional, as in a 120 volt connection coming in the top, which then supplies a 120 24 volt transformer and then goes off to a full wave bridge rectifier and some batteries in the base. But there's a lot more buttons. There's a keypad here and buttons to navigate a menu, and that's because an addressable fire alarm system will most often require programming. Now, addressable fire alarm systems use addressable modules and devices to communicate back and forth to the fire alarm panel. An addressable module will communicate with this fire alarm panel as a small computer would communicate back to a main computer, which is the fire alarm panel itself. Each addressable module or device has its own unique identifier or number or address. So addressable devices can be smoke or heat detectors, or specialty modules, or pull stations. All of them need to be addressable. The wiring to the addressable modules and devices provides both power and two-way communication and is called the signaling line circuit, or SLC for short. We can see here the SLC terminals of an addressable fire alarm system shown on the base, SLC1 and SLC2. Usually, we're using a smaller gauge FAS or fire alarm system cable to prevent signal interference from a device to the fire alarm panel. And sometimes it's shielded and sometimes it isn't. Kind of depends on the specifications of the job and what the engineer requires. Now, these two conductors are not just providing power to my addressable smoke detector. Instead, they're doing a lot more. They are converting communication signals into high frequency signals which travel along the conductors. So the fire alarm panel provides 24 volt simply to power the little device over here, and the device then communicates back its unique identifier number, its operation, as in if it's confirming it's operating correctly, and it also communicates an alarm signal when triggered due to smoke or heat. Now, if we take a look at the wiring of an SLC loop, we'll notice that really it differs very little from that of a conventional Class B. The main difference we'll see is that there is no end-of-line resistor. The last device simply ends, so that's fairly straightforward. So each device then communicates back to the fire alarm panel on the same two conductors simultaneously. The green line shown on the left-hand side is communication, so first device communicates, second device, and third device, all over the same two conductors simultaneously. Addressable fire alarm systems come in three different configurations. They're known as DCLB, DCLA, and DCLC. DCLB is similar in structure to a Class B conventional, but there is no end-of-line resistor. A DCLA is similar in structure to a Class A conventional, and a DCLC is a DCLA system with isolation monitors before and after crossing fire zones in a building. This is an example of a DCLB. Similar wiring to a conventional, but as I said before, no end-of-line resistor. Now, because each one of these devices is communicating simultaneously over the same two conductors back to the fire alarm panel, it means that sometimes some manufacturers will permit something like this. Depending on the fire alarm system, T-tapping or splicing off may be permitted. Supervision is maintained because there is a direct communication addressable system in place. Now, not every manufacturer will permit this, and not every fire alarm engineer. And so it's very important that you check with the specifications to ensure that it is permitted for your particular job. Remember, if one of these wires breaks, we lose communication from this device back to the fire alarm panel, and it will recognize this and go into a trouble condition. So, if this is connected up through the same conductors all the way back, it means that this device is also communicating on the same two conductors. If this wire were to break, the fire alarm panel would notice this and it would say, "Trouble, this device is no longer communicating." Now we can also have a DCLA, and a DCLA is pretty much the same as a conventional Class A. It has a set of return conductors, but remember, there is smart devices. And so it offers the same advantages as the conventional in that if both conductors were to be severed somewhere, we could still have communication from all the objects back to the addressable fire alarm panel. So you have two different paths. Addressable fire alarm systems are specific to the detecting devices. Notification appliances are not manufactured in an addressable variation. This means NAC devices will continue to be terminated at NAC terminals in an addressable fire alarm panel as either Class A or Class B. Sometimes they will be remotely located away from the fire alarm panel with a specialty module. So here's our addressable fire alarm panel, and there are NAC notifying devices or terminals at the top. These can be connected as either Class A conventional or Class B, and the NAC terminals, as we saw in the conventional, will still flip polarity when an alarm condition occurs due to initiation from one of the SLC devices. So here's NAC devices that are Class A, and here's NAC devices that are Class B. Most often, the number of physical NAC terminals will be limited on an addressable fire alarm panel. If more than 2 NAC zones are required, a different system connection with specialty addressable modules would be used. And that's because, well, there's only 2 NAC terminals. How on earth are you going to get more than, 2 zones of NAC? Specialty addressable fire alarm modules allow for the connection of conventional and ancillary equipment back to an SLC loop. So these are all examples of addressable, so tiny little computers that will connect into the SLC loop and communicate back to the fire alarm panel. The first one is called a signal addressable module. This is used to remotely connect conventional notification devices that are a long distance typically from the main fire alarm panel. Now this system must have its own separate power supply to operate the notification devices. This DCL wiring is not going to provide a whole lot of power in order to drive big beefy horn strobes and gongs. Those take a lot of juice, and so this requires its own DC connection in order to supply the NAC devices. These two terminals here will operate the same as the NAC terminals would on a standard fire alarm panel. They will reverse polarity during an alarm condition. Sometimes, if NAC devices are a long distance from the main panel, a booster panel will be used. This is essentially a signal addressable module built into a cabinet with its own charging system and batteries. It then has its own 120 coming in, and that then goes through a rectifier and a signal module which connects to my SLC loop wire here, and I have a set of batteries in here which are providing power in case the building power is dropped, and my NAC devices then wire up to the terminals. A monitor addressable module is used for non-addressable detecting devices, such as pull stations, heat or smoke or sprinkler systems. When they're required to be connected back to an addressable system, I need some way to terminate them. So sometimes this is due to devices not being manufactured in addressable versions. And other times, there's a possibility of upgrading a fire alarm system from conventional to addressable, and you don't want to replace every single device at the building. So now what we can do is take these older conventional pull station devices, send them to an addressable monitor module, which is the equivalent of, remember the term, IDC terminals, and the entire addressable monitor module then connects back to the DCL wiring for our SLC loop. Finally, we have a relay addressable module, and this is used to control additional components during an alarm. These other items could be things like fire doors, fire dampers, or even elevator return. So these are very similar to the dry set of contacts that we saw on a conventional fire alarm panel. So you could use these to control the fire doors, and you could have this module near the fire doors where the supply of energy is to energize their electromagnets. Since most devices are uniquely addressed, the location of a fire can be pinpointed with extreme accuracy in a building. A removed device or broken wire can be pinpointed with extreme accuracy in a building. On a conventional system, when someone pulls the pull station, the whole loop goes into alarm. On an addressable fire alarm system, when a pull station is pulled, the exact device is indicating at the fire alarm panel with its specific ID number, and of course, the whole zone goes into alarm. If a conventional device is removed, the entire zone goes into trouble. The electrician must now go and search for the missing device. On an addressable fire alarm system, the removal of that device will then cause the number to come up of its specific address on the fire alarm panel, and we can then know exactly where that is located in the building. An SLC loop can be exceptionally large. Depending on the capacity of the system, there can be upwards of 100 devices on each loop. The devices can then be programmed into multiple zones. A conventional IDC loop can have many devices, but there will be a separate loop for each zone in the building. So for this one, conventional, we've got 12 zones, which means for the IDC, I've got 12 different pipes that have to come back for all of my individual IDC loops. All the devices have to connect together on their own individual loop, and then I need to bring that loop wiring back. On an addressable fire alarm system, I could have the same number of devices and same number of zones. However, now there's only a requirement for me to bring back one wire, and that's because absolutely everything can be terminated together and it's all uniquely addressed. If it's all uniquely addressed, then all I have to do is in the programming address or take the address for this device and note in the program that it's zone number 12. These two, zone number 11. And instead of having individual cables going all the way back to the fire alarm panel, I'm only using two terminals on the SLC loop for all of these devices. Buildings are separated into different fire zones as per the National Building Code. This helps to reduce the spread of fire throughout a building. Buildings are designed with fire-rated walls and self-closing doors, which should be able to sustain the heat of a fire for a specified number of hours. In this particular addressable DCLA fire alarm system, when we have one wire that goes around and connects all the devices, there comes a problem. And that's because we have high frequencies that are introduced onto these conductors. If a fire burns through two SLC conductors, it is likely a short circuit which will result. A short circuit in these conductors will disrupt all communication of devices throughout the SLC loop. And so what I mean is this. There's my FAS cable, it's getting burned through, insulation burned through, and two wires get shorted together due to melting. What this will result in is an interruption of communication between any device anywhere on those two wires. And so that would be a big problem. If we look at it more specifically in a limited range here with the devices, I've got here a signaling module for my NAC devices, and it's on my SLC loop here, and there's my separate DC source at the top. Right now, we have communication between all the objects. However, if I had a fire within this particular area or room and a short circuit developed, there would be zero communication capable between any device. Remember, On an addressable system, these are little computers that are communicating back to the main fire alarm panel. If there's no potential difference between these two wires, there's no communication that can take place. To prevent this possibility, fault isolation addressable modules must be connected into the DCLA loop immediately before and after crossing a fire zone or floor of a building. Sometimes these are independent isolation modules in their own box, and other times these are built into the base of a detector. So on our original installation, we would then add 4 of these fault isolation modules, one before and one after the firewall. Now, the name will change. We have a DCLC system, and a DCLC is simply a DCLA with fault isolation modules. So now we have communication between everything. Let's go through the same scenario. Fire in the room, wires short together. What the fault isolation modules will do is isolate the fault, thereby suspending the connection to the remainder of the wiring, and they work in pairs. So that means that everything else in the system is able to still communicate, and we haven't prevented the overall, we haven't hamstrung the entire system by one short-circuited cable. The modules isolate the short circuit, and the majority of the fire alarm system remains operational. Dual-stage pull stations can be used in DCLB, DCLA, or DCLC addressable systems. And the dual-stage addressable pull stations have the same number of SLC terminations as a standard single-stage pull station. A key is used in the same way as in initiating the second stage as what's seen in the conventional system. What's interesting is that the way it accomplishes this is by use of the small addressable module. It introduces those signals, or the high-frequency communication protocols, onto the same two conductors. So now we have both the alert and the alarm conditions transmitted over the same two conductors. So operation is identical to conventional, however the wiring is vastly simplified.